Hello, welcome all to Anadeep, your study buddy. We have started with the lecture series on question bank for the 12th class student, and we discussed about the integration topic in the previous video. We are going to continue with the same topic but with a different method that is called integration by parts. Integration by parts. This method is useful when the integral is expressed as a product of two different types of functions, one of which can be differentiated and the other can be integrated conveniently. So following is the formula that we make use of when we solve the problem on integration by parts. Integral of u into v dx is equal to u integral v dx minus integral of d by dx of u into integral of v dx. So this formula is very helpful when we have two functions of x and which are in product inside the integral. We make use of the Liard rule when we are solving the problem by integration by parts and when we want to decide which is u function and which is v. So it is identified by the precedence given below. I, when we are talking about Liard, L stand for logarithmic, I inverse trigonometric function, A algebraic function, T trigonometric function, and E exponential function. So let us see how to evaluate problems using the integration by parts. So first of all, we have to recollect the formula. Integration of u into v dx is u integral of v dx. Same term copied inside the integral. So we have a double integration sign, v dx multiplied by derivative of u. So this is what is the formula that we have to remember. And now let us see when we want to decide which is u and which is v. Already we have discussed when we discuss about the formulas on integration by parts. We need to remember the Liard rule. What does the Liard rule tells you? L stands from logarithmic. So if you have a term of log x, log of x square, so involving a term which has a log, that should be evaluated first. Then second precedence is inverse trigonometric. For example, sine inverse of x, cos inverse of x. Third is algebraic. Algebraic, it can be an expression, it can be a simply x term. So it can be 2x, x square, anything which involves the expression that becomes a algebraic. Then next is a trigonometric. As you can guess, cos x, tan x, all these are the trigonometric functions or these are terms. And lastly, it is an exponential, that is e raised to x. Let us now evaluate first problem. It says evaluate integral of log x dx. Now as soon as student sees the log x term, they urge to write the answer as 1 by x and that is it. But there is no direct formula for log x. But integration of the reverse is true. Integration of 1 upon x dx is log x. So for this, the answer 1 is absolutely wrong. So what is the method to simplify this problem? So for this, we have to multiply log x by 1. So this is the adjustment that we are making. So log x into 1 dx. Now as you can guess which is u and which is v, logarithmic x or term is always has a higher precedence. So u becomes log x and 1 can be the algebraic term. So here it becomes v. Let us apply the formula. So u as it is, that is log x as it is, integral of 1 dx minus, now this term we need to copy it down again. So it is 1 dx multiplied by the derivative of u, that is log x. So what I am getting here is log x. Now what is the integral of 1 dx? Correct, that is x. Minus, again it is x as it is. Same answer will be there, right? Same term. Multiplied by derivative of log x is 1 by x. So what remains inside is, it is equal to x log x minus integral of, so x log x minus 1 dx is remaining. So what we have? X log x. Again the integration of 1 dx is x and constant of integration is plus c. I can take out x common outside. I can get log x minus 1 plus c. This is what is the answer when you want to evaluate integral of log x. Let us now solve another problem. It says integrate x into tan inverse of x into dx. So here we need to identify which is u and which is v. So I can see this is inverse trigonometric and this is algebraic. So LIATE. So this is my U and this is my V, right? So let us apply the formula for integration by parts. U, that is tan inverse of x integration of x dx minus integration of x dx derivative of tan inverse of x dx. Now, what is integral of x? It is x square by 2. So, same term I will be getting inside. And what is the derivative of tan inverse of x? It is 1 upon 1 plus x square. So, what I can see here, let me call this as one integral, sub-integral as I1. So, let us solve I1 and what I1, what I am getting is term of x square upon 1 plus x square dx. I am taking this 1 by 2 outside. So, here we can adjust plus 1 minus 1 so that I will be getting a same term here inside the integral. So, this is what I will be making an adjustment to simplify the integral. So, I will be getting two terms here, 1 plus x square upon 1 plus x square dx minus 1 upon 1 plus x square dx, right? So, what I am getting here, after this I am getting answer as it is 1 dx and integral of 1 dx is x. Now, here minus, what is integral of 1 upon 1 plus x square? It is simply tan inverse of x plus c. Now, let us write the final answer. So, my I becomes, I have a term of x square by 2 tan inverse of x, and this is what is the value that I have obtained. So, the final answer will be I will be x square by 2. This is the first term that I have, and for the I1, that is what is the answer we have obtained. It should be multiplied by 1 by 2. So, plus 1 by 2 x minus tan inverse of x plus c. That is what is the final answer. Now, let us evaluate the next problem. It says I is equal to cosec cube x dx. So, the way to solve this problem is you can rewrite it as cosec x into cosec square x dx. So, I am just rewriting the term of cosec cube x as cosec x into cosec square x. So, I can select any term as u and v because they are the same terms. So, let me call it cosec as 1 and applying the integration by part rule. What I will be getting is cosec x integration of cosec square x dx minus cosec square x dx derivative of into derivative of what is u? It is cosec x. Now, what is the integral of cosec square x? Yes, it is minus cot x. What is again? It is same thing that will get repeated, minus cot x multiplied by what is the derivative of cosec x? It is cosec x into cot x minus of cosec x into cot x dx, right? So, this is what we are getting. So, inside integral I am getting minus minus, it will become plus, but the term is cosec x and this become the cot square x. This first term will be as it is. Now, what is the formula? What is the identity for cot? It is 1 plus cot square x is equal to cosec square x. So, I can replace this cot square x by cosec square x minus 1. So, what I will be getting instead of this, I will be rewriting it as cosec x into cosec square x minus 1 dx. And when I open the bracket, I will be getting a term of cosec cube x minus integral of cosec x dx, right? So, this is what I will be getting, and on here the same term we have to copy it down. Now, if you can observe, okay, so this minus minus will become plus. This term is what I have started with. So, this I can replace it by I. So, what I am getting in the next step is first term minus cosec x cot x will be as it is. Then we have a term of integration of cosec x. What is the formula? It is log of, so it is minus side, and it is plus log of, what is the term? Tan x by 2 plus c. So I can transfer I on the left hand side. I am getting 2I is equal to, I am taking this term first. So log of tan x by 2 minus cosec x cot x plus c. And here simply the I will become, I have to transfer this 1 by 2 here. First term is log of tan x by 2 and minus, here it is cosec x into cot x plus c. This is what is the final answer. Now attempt the problem given on the screen. Solve the following integrals. Integral of e raised to 2x into sine 3x and integral of sec cube x. We have already discussed about the method to solve these problems. Do solve them and write your answers in comment box. So this is how we are going to solve the problems by the method of integration by parts. So I hope this method is clear to you. There are extra problems given in this video, so do attempt them, write your answer in the comment box. And if you find this video helpful, please subscribe to like and comment. And we will see you very soon. Thank you.